Sheet metal working are cuttings and forming operations performed on a relatively thin sheet of metal. The thickness of the sheet metal range is between 0.4 millimeters up to 6 millimeters, and thickness of the stock above 6 millimeters. The operation is usually performed as a cold working. Sheet and plate metal parts for consumer and industrial products such as the automobile and trucks, the airplanes, railways, cars, and locomotives. The main advantages of the sheet metal parts is the high strength, good dimensional accuracy, the good service finishing, and their relatively low cost make them cost efficient. Also, the economical mass production for large quantities is possible. Sheet metal working terminology, including the punch and die tooling to perform cutting, bending, and drawing. The stamping process, where the machine tool that performs most of the work sheet metal operation. Finally, we have the stamping, which is capable of producing the sheet metal products. The basic types of the sheet metal processes, including the cutting, the bending, and the drawing. The cutting is including the shearing to separate the large parts, blanking to cut the parts perimeters out of the sheet metal for subsequent processes, the punching to make the holes in the sheet metal, and the trimming. Shearing is a sheet metal cutting operation along a straight line between two cutting edges. Shearing is typically used to cut a large sheet into smaller sections for subsequent press working operations. It is performed on a machine called the power shears or the squaring shears. The upper plate of the power shears is often inclined to reduce the required cutting force in this operation. Blanking involves cutting of the sheet metal along a closed outline in a single step to separate the piece from the surrounding stock. The part that is cut out of the desired product in the operation and is called the blank. Punching is similar to blanking, except that it produces a hole, and the separated piece is scrap, called the slug. The remaining stock is the desired part. Trimming is a cutting operation performed on a formed part to remove the excess metal and establish the size. Bending in sheet metal work is defined as straining of the metal around straight axis. During the bending operation, the metal on the inside of the neutral plane is compressed, while the metal on the outside of the neutral plane is stretched. The metal is plastically deformed so that the bend takes a permanent set upon the removal of the stresses that caused it. The bending produced little or no changes in the thickness of the sheet metal. The bending operations are performed using a punch and die tooling. Two common bending methods and associated toolings are the V-bending, performed with a V-die, and the edge bending, performed with the whipping die. In V-bending, the sheet metal is bent between the V-shape punch and die, included in angles ranging from a very obtuse to a very acute can be made with the V-dies. The V-bending generally is used for low production operations, and it is often performed on a pressure brake, and the associated V-dies are relatively simple and inexpensive. The edge bending involved the cantilever loading of the sheet metal. A pressure pad is used to apply the force to hold the base of the part against the die, while the punch forces the part to yield and bend over the edge of the die. Edge bending is limited to a bend of 90 or less degree. More complicated webbing dies can be designed for the bend angles greater than 90 degree. Because of the pressure pad, opening dies are more complicated and costly than the V dies, and are generally used for the high production works. Spring back is an increase in the included angle of the bent part relative to the included angle of the forming tool after the tool is removed. The reasons for the spring back is that when the bending pressure is removed, elastic energy remains in the bent part, causing it to recover partially toward its original shape. Spring back results in decrease in bend angle and an increase in the bend radius. Drawing is a sheet metal forming to make a cup-shaped or box-shaped or other complex curved, hollow-shaped parts. The sheet metal blank is positioned over the die cavity, and then the punch pushes the metal into the opening. Products can include the beverage cans, the ammunition shells, the automobile body panels, and also known as a DB drawing to distinguish it from the wire and the wire drawing. Drawing of the cup-shaped parts is the basic drawing operation. If the shape change required by the part design is too severe, complete forming of the part may require more than one drawing step. The second drawing step and any other further drawing step, if needed, are referred as the redrawing. Each of the following shapes presents its own unique technical problems in the drawings, like the square or the rectangular boxes, the stepped cups, the cones, the cups with the spherical rather than the flat bases, and the irregular curved forms, as in the automobile body panels. The ironing achieves a thinning and elongation of the wall in the drawn cup. In DV drawing, the flanges is compressed by the squeezing action of the blank perimeters, seeking for the smaller circumference as it is drawn toward the die opening. Because of this compression, the sheet metal near the outer edge of the blank becomes thicker as it's moved inward. If the thickness of the stock is greater than the clearance between the punch and the die, it will be then squeezed into the size of the clearance, and the process known as the ironing. Imposing is a forming operation used to create the indentations in the sheet, such as a raised lettering or straining grips. Some stretching and thinning of the metals are involved. This operation may seem as similar to the coining. However, the imposing dies possess the matching cavities contours and the punch containing the positive contours and the die containing the negative. With the coining, the dies may have acquired different cavities in the two die halves, thus causing more significant metal deformation than the imposing. The Cornell process uses a thick rubber pad or other flexible material to form the sheet metal over a positive foam block. The rubber pad is confined in a steel container. As the run descends, the rubber will gradually surround the sheet and applying a pressure to deform it to the shape of the formed block. Usually, this process is limited to relatively shallow forms because the pressure developed by the rubber, which is up to 10 megapascal, are not efficient to prevent the rippling in the deeper formed parts. The hydroforming is similar to the Goran process. The difference is that the substitutes rubber diaphragm filled with the hydraulic fluids in the place of the thick rubber pad. This will allow the pressure that forms at the work part to be increased with up to 100 megapascal, thus preventing the wrinkling in the deep formed parts. In fact, deeper drawing can be achieved with the hydroform process than with the conventional deep drawing. This is because the uniform pressure of the hydroforming forces the work to contact with the punch throughout the length, thus increasing the friction and reducing tensile stresses that cause the tearing at the base of the drawn cup. There's a recent application of using a 3D printed forming mold for lower cost and short-term production or just for the prototyping. Wedge forming is a sheet metal deformation process in which the sheet metal is intentionally stretched and at the same time bent in order to achieve the shape change. For a relatively simple and gradual bend, the work part is gripped by one or more jaws on each end of it, and then stretched and bent over the positive die containing the desired form. The metal is stressed in tension to a level above the yield point, and when the tension loading is released, the metal has been plastically deformed. Roll bending is an operation in which a large sheet metal or plate metal parts are formed into a curved sections by means of the rolls arrangements. As the sheet passes between the rolls are brought towards each other to a configuration that achieves the desired radius of the curvature on the work. The components for the large storage tanks and the pressure vessels are fabricated by the roll bending. A related operation is the roll straining, in which a non-flat sheet or other cross-sections forms are going to be strained by passing them between the series of rolls. Roll forming, and also called the contour roll forming, is a continuous bending process in which the opposing rolls are used to produce along sections of the form shapes from a coil or strip stock. Several pairs of rolls are usually required to accomplish the bending of the stock into the desired shape. Bending is a metal forming process in which an axial symmetric part is gradually shaped over the mandrel or formed by means of the rounded tool or rulers. The tool or the roller applies a very localized pressure to deform the work part by an axial and radial motions over the surface of the part. The basic geometry shapes typically produced by the spinning include the cups, the cones, the hemispheres, and the tubes. The spinning can be classified into manual spinning and the power spinning. Other types of the spinning include the shear spinning and the tube spinning. The explosive forming is the use of the explosive charge to form a sheet or a plate metal into a die cavity. The explosive charge causes a shock wave whose energy is transmitted to a forced part into a cavity. The applications are the large parts and typical aerospace industry parts. In electromagnetic forming, the sheet metal is deformed by a mechanical force of the electromagnetic field induced in the work part by an energized coil. Presently, the most widely used in the HERF processes. The main applications are for the tubular parts. Electrohydraulic forming is an HERF process in which the shock wave to deform the work into the die cavity is generated by discharge of the electrical energy between the two electrodes submerged in the transmission fluid, which may again to be the water. Owing to its principle of operation, this process is called the electrical discharge forming. Electrical energy is accumulated in the large capacitors and then it's going to release to the electrodes. The electrohydraulic forming is similar to the explosive forming. The main difference in the method of the generating of the energy and the smaller amount of the energy that are released. And this limits the electrohydraulic forming to much smaller part sizes. Bending of the tube stock is more difficult than the sheet stock because the tube tends to collapse and fold when attempts are made to bend it. Some special flexible mandrels are usually going to be inserted into the tube prior to the bending to support the walls during the operation.